Good morning, everyone. This video is to explain assignment number 5, which is that 24-question worksheet titled Practice with Exponents. All right, anytime you're working on any of these problems with the rules of exponents, I highly recommend you have a rules of exponents cheat sheet off to the side. So this is a list of all of our rules. So what you can do is you can pause the video and copy these down if you haven't done so already. But just keep this handy when you're working with this worksheet, okay? So let's go. First question, we've got a squared to the third power. All right, this is our expanded power rule. So if we have x to the power of a to the power of b, we keep the base, multiply the exponents. So keep the base a, multiply 2 times 3, and you get 6, and you get a to the 6th power. For the second one, it says which equation is equivalent to y equals 10 to the x. You can just go through these one at a time and apply our negative exponent rule, which is down here. We have 2 of them. X to the negative a is 1 over x to the positive a, or 1 over x to the negative a equals x over positive a. Remember, negative exponent just means reciprocal. So if we have 1 over 10 to the x power, well, nothing changes there. It just is 1 over 10 to the x power. For b, we have negative 10 to the negative x. So we take the reciprocal of 10 because it's not negative 10 in parentheses. It's just 10 to the power of negative x. So we're negating 1 over 10, and that's being raised to the positive x power. And that's not the same thing as 10 to the x. For the third one, we have 1 over 10 to the negative x. Well, 1 over 10, we take the reciprocal. We get 10 over 1. Raise that to the x power, and that's just 10 to the x. And that's why that's the answer. For number 3, we've got negative 3x squared y cubed, and that whole expression is being cubed. So inside the parentheses is negative 3 times x squared times y cubed. There's no addition or subtraction, it's all multiplication. So we can use our expanded power rule, this one that says x times y to the power of a. Just means everything inside gets raised to that power of a. So it's x to the a times y to the a. Be careful, this is not true for when you are adding or subtracting, only when you're multiplying or dividing. So we get negative 3. Notice the negative 3 is in parentheses to the third power. We've got x squared to the third power, and you got y cubed to the third power. Negative 3 cubed is negative 3 times negative 3 times negative 3 is negative 27. X squared cubed, well, we use the same rule we did in our first problem, where when you have a power raised to a power, you multiply. So we keep it x, and we're multiplying 2 times 3, and we get x to the 6th. Same thing with the y's. You get y cubed cubed. That becomes y to the power of 3 times 3, which is 9. So it's a negative 27x to the 6th, y to the 9th. All right, number 4 requires a little bit of thinking. You got 3 to the x times y equals 3 to the x plus 1. What is the value of y? First thing first, all of these rules only work when you're dealing with, well, not all of them, I apologize, but most of these rules, if you have the power rule, the quotient rule, right, all these rules is when you have common bases. So if you look at this problem, it is set up exactly like our first rule, our product rule. We've got x to the power of a times x to the power of b equals x to the a plus b. 2 things being multiplied equals 1 term here, right? So we know we need to have common bases in order for this to work. So the base has to be a 3. Okay? Now the question is, x plus something is equal to x plus 1. Because when you're multiplying common bases, you add the exponents. So the only thing that's missing is that plus 1. So you know this has to be 3 to the first power. Number 5 is simply multiplication. 5x cubed times 3x squared. 5 times 3 is 15. X cubed times x squared is the product rule. Keep the base, add the exponents. 3 plus 2 is 5, so we get 15x to the 5th power. Same thing with number 6. Negative 2a cubed times negative 3a squared. Remember, product is multiplication. Negative 2 times negative 3 is positive 6. Negative times negative is positive. A cubed times a squared is a to the power of 3 plus 2, which is again a to the 5th power. So it's just 6a to the 5th power. For number 7, we have 3a times 3a plus 4 raised to the 3rd power. So in this one, only the 3 to the power of a plus 4 is being raised to the 3rd power. So we multiply. When you have a power raised to a power, you multiply them. So we keep this 3 to the a times. It becomes 3 to the 3 times a plus 4, because it's power to a power. You're multiplying. You must distribute that 3. So it becomes 3a plus 12. We're using the distributive property. 3 times a is 3a. 3 times 4 is 12. And they're being added. So then we have 3 to the a times 3 to the a plus 12. Common base being multiplied, you add the exponent. So it becomes 3 to the a plus 3a plus 12. A plus 3a is 4a, and that's why the answer is C. For number 8, we've got a times t cubed s to the negative 5th all over 4 times t to the negative 1st power s squared. All right, the first thing we do is we look at the coefficients. 8 divided by 4 gives us 2. So we're just going to have 2. Sorry. For the second one, we have t cubed over t to the negative 1. You're dividing. When you're dividing common bases, you subtract the exponents. So you get t to the 3 minus negative 1. 3 minus negative 1 is positive 4, so the t's is t to the 4th power. S to the negative 5th over s squared is s to the negative 5 minus 2, which is negative 7. So we get 2 t to the 4th s to the negative 7th. And since that s is being raised to a negative exponent, it's going to bump down to the denominator and become a s to the positive 7th. So that's why the answer is A. All right, for number 9, if we were in the classroom, I'd tell you to just plug that directly into your calculator, press enter, and get an answer. But unfortunately, we don't have those calculators at home. So you can still try it with the calculator that I posted. I posted a link to a calculator in the classroom, stream. So take a look at that. But you could still work this out. All right, it's good practice anyway. So 2 to the negative 3rd power plus 3 to the negative 2nd power all over 8 to the negative 1st power. All right, so 2 to the negative 3rd just becomes 1 over 2 to the positive 3rd. 3 to the negative 2nd power is 1 over 3 squared. So you're adding those together. And all that is over 1 over 8, because that's 8 to the negative 1st power. So we get 2 cubed is 8, 3 squared is 9, 1 over 8 plus 1 over 9. All right, the way we add fractions, you got to get a common denominator. So we're going to multiply 1 over 8 times 9 over 9, and 1 over 9 times 8 over 8. And we get 9 over 72 plus 8 over 72, which is 17 over 72. Okay, all I did was I added these fractions together. And then that's being divided by 1 over 8. So it's 17 over 72 divided by 1 over 8. Well, how do we divide fractions? Keep, change to multiplication, flip 1 over 8 to 8 over 1. We can cross cancel. 8 goes into itself once. It goes into 72 9 times. And it just becomes 17 over 9, which is choice A. Okay, again, you might need to rewind and go over that again. If you have to, then just go ahead and do that. Number 10 is the same exact type of problem, but now we're subtracting and it's being raised to a negative exponent. So there's a lot going on here. And as you can see, I made a silly mistake too. So there's a lot of room for error. So just be careful. You get 3 to the negative 2nd power minus 3 to the negative 1st power all over 3 to the negative 1st power. I wrote over, I think that's what it says. Yes. So we get 1 over 3 squared minus 1 over 3 all over 1 over 3. And that whole thing is being raised to the negative 2nd power. Now, this is not the expanded power rule. You cannot raise everything to that negative 2nd power. Why? Because of this minus sign in the middle. Okay? It only works when you're multiplying or dividing. Because of that, you cannot raise it to the negative 2nd power. You have to simplify what's inside first. So we have 1 over 9 minus 1 over 3, all over 1 over 3, raised to the negative 2nd power. So that's 1/9 minus 3/9, because you have to have common denominators, okay? Oops. All over 1/3. So 1/9 minus 3/9 is negative 2/9, all over 1/3. So negative 2/9 divided by 1 over 3 is the same thing as negative 2/9 times 3 over 1, right? We're just skipping a step here that I wrote in the other problem. And then we can cross cancel. 3 goes into itself 1 time. 3 goes into 9 3 times. So it's going to become negative 2 over 3. That's then being raised to the negative 2nd power. That negative means we flip this, and so it becomes negative 3 over 2 to the positive square. And then we can use this rule where we have x over y to the a becomes x to the a over y to the a. So first off, since we're squaring a negative, it becomes positive. 3 squared is 9, 2 squared is 4, and that's why the answer is B. If for either questions 9 or 10 you still don't understand it, just shoot me an email and I will try to video chat with you or something to explain it another way. All right, we then follow up with a very, very easy question, 3 plus 5 to the power of 0, right? When you've got a number that's not 0 raised to the power of 0, it just equals 1. So 5 to the power of 0 is 1. We get 3 plus 1, which is 4. All right, for number 12, you can see I put what kind of looks like an asterisk next to it. We've got negative 4 to the negative second power, okay? We take the reciprocal of that 4, it becomes 1 over 4 to the positive squared power, and then we negate it, and we get negative 1 over 16. Be careful, okay? Negative 4 to the negative second power is not equal to, there we go, is not equal to negative 4 to the negative second power, okay? These are not the same thing, because if you have this here, then you will be 1 over negative 4 squared, which will be positive 1 over 16, okay? That is not the answer. The answer is negative 1 over 16. That negative is not included in the exponent, and in the base being raised to that exponent, excuse me. And if you know your rules of operations, all right, exponents come first. Right, PEMDAS, parentheses, exponents. So you'd be raising the 4 to the negative second power, then negating it at the end. So be very careful. There's a big difference with how it's written here as opposed to here. Okay, so just be conscious of that. Whoops. 13, we've got a squared over 2b cubed. All right, that whole thing being squared. So this is a couple of our rules together is actually these two. All right, when you have a fraction raised to an exponent, everything gets the exponent, and when you're multiplying raised to an exponent, everything gets the exponent. So watch. You've got a squared squared. Well, you're going to be squaring our numerator, which is a squared. Power raised to a power, you multiply them. So it's a to the 2 times 2. Then down at the bottom, you've got 2b cubed squared, and then we have to give that square to the 2, so it becomes 2 squared. And b cubed, which becomes b cubed, and then we're multiplying 3 times 2. So it becomes a to the 4th over 2 squared, which is 4b to the 6th power. For number 14, okay, we have the square root of x to the 6th power. Remember, anytime you have a radical with a blank index, it's really 2. It's not 1, it's 2. So we have x to the power of 6 over 2 because of our fractional exponent rule, which is x to the a over b equals the bth root of x to the a. So the 6 becomes the numerator, and that index of 2 becomes the denominator, and 6 divided by 2 is 3, so it's x cubed. Number 15, same type of problem. It just becomes a to the power of 12 over 3 because the index is the denominator, and 12 divided by 3 is 4, so it's just a to the 4th. For 16, there's a couple ways we can do this. If you think back to when we did radicals back in October, you can do it that way, where in order for it to be a perfect cube, it's got to be divisible by 3. Well, this is why it has to be divisible by 3, because the cube root, it means a power of 1/3. So you have negative 8 to the 1/3 power, which just becomes negative 2, right? Because the cube root of negative 8 is negative 2. All right, then we raise our 6. X to the 6 becomes x to the 6 over 3 because it's got an index of 3. And our y cubed becomes y to the 3 over 3. So it's negative 2. 6 divided by 3 is 2. That's why it's x squared. And 3 divided by 3 is 1. That's why it's just y. So it's negative 2 x squared y. For number 17, this is another one I probably would have just said to you, chuck it in the calculator and see what you get. But we don't have that luxury here. So we have 16 to the 3/4 power becomes the 4th root of 16, everything cubed. I'm not going to cube 16. I'm going to figure out the 4th root of that first, but you could do it the other way. So the 4th root of 16 is 2 because 2 times 2 is 4. times 2 is 8, times 2 is 16. So that's 2 times itself 4 times, gives you 16. And then we cube that, and 2 cubed is 8. All right, number 18, another problem. You got to be very careful with what's being raised to that exponent. All right, just the x is being raised to that 1/2 power, not the 4. Okay, it's not 4x in parentheses to the power of 1/2. The 4 is not being raised, right? It's not written like this. These mean different things, so be careful. So only that x is being raised to that exponent, so that's why the answer is C. If it were written as 4x to the power of 1/2, then it would be 2 radical x, so just be careful. For number 19, 1 over n to the negative 2/3 power. Well, let's take care of that negative first, and we take the reciprocal. It becomes n over 1 to the positive 2/3 power, and then we just put that in radical form. The denominator becomes the index, and that numerator becomes the exponent, so that's why it is the cube root of n squared. For number 20, now you can see what I'm talking about. Here, we have 3b in parentheses being raised to 2 over d. Up top, we didn't have it in parentheses. It was just the x. The 4 was not part of it. But here it's in parentheses. So that 3b, that whole expression, is being raised to the 2 over d power. So we put the 3b under the radical. That's our radicand. The d is our denominator, so it becomes the index. And then that 2 of the numerator is squared. And remember, it can go either inside or outside, but it's not written inside. So that's why the answer is B. All right, 21 through 24. These were the tough ones, right? Regents questions. So the first one, m squared over m to the 1/3 power. Whole thing being raised to the negative 1/2. It's not bad. It's not bad. It looks bad, but it's not bad. It's just our regular rules of exponents, right? Inside the parentheses, we've just got, x to the a divided by x to the b, or x to the a over x to the b. That's, there it is. It's really what this is, something over something else, common base. So what do? We subtract the exponents. So you're going to have to do m to the power of 2 minus 1/3. Well, 2 minus 1/3, you should know how to do that. I'm sorry. But think of it as 2 over 1 minus 1 over 3. You got to have common bases of 3. So we got to multiply 2 over 1 times 3 over 3, and we get 6 over 3. So it becomes m to the 6 over 3 minus 1 over 3. And that whole thing is still being raised to that negative 1/2 power. So you get 6 over 3 minus 1 over 3 is 5 over 3. So it's m to the 5/3 power. That's being raised to the negative 1/2. Okay, so the rule is when you've got a power raised to a power, what do? You multiply them. So you're going to have multiplying these exponents. So you have m to the 5/3 times negative 1/2, right? M to the 5/3 times negative 1/2. You just go straight across. First off, positive times negative is negative. 5 times 1 is 5. 3 times 2 is 6. So it just becomes m to the negative 5 over 6. Then it becomes our negative exponent rule. X to the negative a becomes 1 over x to the positive a. So m to the negative 5 over 6 becomes 1 over m to the positive 5 over 6. And then the last step is we have our fractional exponent here. X to the a over b equals b, the bth root of x to the a. So we have m to the 5 over 6 becomes the 6th root of m to the 5th. All right. It looks difficult, but this is just testing just about every single one of your rules here. So just go through it step by step. Don't be overwhelmed by it. It's not bad. But the answer is C. For number 22, we just have to figure out which is equivalent to 1 divided by the 6th root of x. That just means 1 over the 6th root of x, like that. So we've got three scenarios here. The 6th root of x divided by the 3rd root of x, x to the 1/6 divided by x to the 1/3, and x to the negative 1 over 6. So let's take it piece by piece. All right, the first scenario, well, the 6th root of x over the 3rd root of x, that's just x to the 1/6 divided by x to the 1/3. When we're dividing common bases, we subtract the exponents. 1/6 minus 1/3 becomes 1/6 minus 2/6, which is negative 1/6. So we get x to the negative 1/6 power, which is 1 over x to the 1/6, which is indeed 1 over the 6th root of x. Okay, so 1 works. Now scenario 2, you could see, is x to the 1/6 divided by x to the 1/3 power. And oh, wait a minute, we just did that. We just did that same exact problem. So I know it's going to work because we get 1 over 6 minus 1 over 3, which is the 6th root of x. Fine. And then the third scenario is x to the negative 1 over 6. And wait a minute, we just did that here too. X to the negative 1 over 6. So we know that that is 1 over x to the 1/6, which is the 6th root of x. So all 3 of them work, which is why our answer is A. All right, strap in, folks. Here is the toughie of the whole entire worksheet. We've got negative 54 x to the 9th over y to the 4th to the power of 2/3. Okay, so first, sorry, the video just hit its limit. So downstairs, we've got the cube root of 8. And we're going to break that up into the cube root of y to the 6 times the cube root of y squared, because y to the 6 is the largest perfect cube that goes into that. And the cube root of y to the 6 is y squared. And you just have y squared times the cube root of y squared on the bottom, which is why the final answer is A. That question is the one question here that was a doozy, but doable. Much easier with the calculator, though. And finally, for the last question, number 24, we've got the cube root of x times the square root of x. It says as a single term with a rational exponent. Keyword rational exponent. So you want this in exponential form, not radical form. So the cube root of x becomes x to the 1/3. The square root of x becomes x to the 1/2. Right? When we're multiplying common bases, we add the exponents 1/3 plus 1/2. Get a common denominator of 6. 2/6 plus 3/6 is x to the 5 over 6. All right. I hope that helped you understand this. If not, again, email me and I'll try to answer your questions the best I can. Okay. We can do video chat or something. We'll figure something out. But please email me if you have questions. Take care, guys.